Hey folks, it's Willie here. Today I'm going to be live coding and go into how one might solve Leetcode question number 1, twosome. It's a very famous problem, and although it may not be seen as often in interviews due to how well known it's become, it is still a very good question to have under your belt. During this video, I'll be going over a number of different solutions to the problem and the space-time complexity trade-offs in each. I'll be coding in Python, which I think is a brilliant language to be using in general for interviews due to its brevity and ease of use. So let's get started. Let's go over the problem itself. So given an array of integers, return indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. And we're given an example. So given nums 2, 7, 11, and 15, our target is 9, and because 2 plus 7 is equal to 9, we can return 0 and 1 indices as our answer. Cool. So how do we approach this? Well, something pretty straightforward that we could do is we can loop through all the numbers in our array, and then for each current index and number, we can loop over the rest of our array. And if the number in our first loop and the number in our inner loop add up to our target, then we'll have our answer and we can directly return our index. If not, we continue looping until we've reached a solution or not. So that's a pretty straightforward method. It's a pretty brute force method to use. It may not be the best solution, but it is pretty easy to code up. So we'll start with that as our first solution. So we'll have a for loop for I num and enumerate nums. We also need an inner for loop, so I'm going to be using the range function. For j in range, we'll start with the index I plus 1 to the end of the list. And then we'll check our second number. So our second number will be equal to nums at index j. Cool. And then now all we need to do is we need to check whether num and num2 add up to target. So if num plus num2 is equal to our target, then we can return the two indices corresponding to our two numbers. Pretty easy. If we loop over all our numbers and we still haven't found a solution, then we'll probably want to raise an exception since we should indeed be having a solution. So we'll return exception. Let's say it could not find solution. Great. Let's run our code on our basic test case. That passes. Awesome. We'll submit and see if it passes through all the Leetcode test cases. And it does. We can see that our solution is actually pretty slow. It takes about 6 to 7 minutes to run through all the test cases, and it's faster than only 5% of Python online submissions, which is pretty bad. In terms of memory usage, it's actually very good. It's less than 76% of other Python online submissions. And we'll talk a little bit into why that is and how we can improve this runtime. So let's look back in our algorithm. So what are we doing? We're doing a outer loop that loops through all the numbers in our array. So that's linear. We also have an additional inner loop. That inner loop will be looping over less than, let's say n is the number of numbers that we have, less than n. It averages out to about n over 2, which is still linear. And so we have a nested for loop, both of which are linear, and that's an overall O of n squared runtime, which is pretty bad. And we have some constant operations inside. In terms of space, we're actually not using any other data structures, and that's why our memory usage is pretty good. But O of n squared as our runtime is not good. how can we improve that? Well, Python actually has a data structure called a dictionary. That's a hash map for those of you familiar with other languages or the general term. And using that hash map, we can negate the need to have a nested for loop. We can actually loop over all the numbers in our list and store those numbers into our hash map. And then as we iterate, we can do a constant time lookup to see if any number that we're currently looking for is in our hash map or that we've seen already. And that might make more sense once we look at the code. So let's do that. We'll need a hash map, obviously, so let's initialize one. The dictionary here. We'll need to, again, loop through our array. And then we need to calculate the second number that we're looking for to complete our sum. And so num2 will be equal to target minus num. And this will ensure that num plus num2 is equal to our target. Let's get to that later. We first need to add all the elements that we want to our hash map. To do that, we'll just do num map num is equal to I, and we're including the number as our key and the index as our value, and that will allow us to do quick lookups for our number that we're looking for. In our second iteration, we'll again loop over our array. As I said before, we calculate our second number, and then if num2 is in num map, so if we've seen that number that we're currently looking for, then we can return the list of the indices that we want. So that would be I and the index corresponding to num2, which will be that. And as before, we will raise an exception if we've looped fully through our array. Let's run our code. Passes that, and then we'll submit. And we see that we actually error out. And this is because our algorithm at the moment actually incorrectly identifies the first index, the 0 index, twice. And we can see from our problem that we actually cannot use the same element twice. So let's fix that. We can fix that pretty easily by just adding an additional check here and making sure that our current index I is not equal to the index corresponding to num2. With that, let's try and submit once again. And we see that it does, in fact, pass our test cases. Our runtime has improved drastically. I think we're looking at something like 5% before. Now we're better than 75% of Python 3 users. That's pretty good. Our memory usage has, however, gone down, and this is sort of the trade-off, right, between what we were doing before. We were using very little memory, but we had a pretty terrible runtime. Now we've got a much better runtime. We have basically a linear set of code here. Again, we're looping through our array, and we're doing some constant operations here. Lookups in a hash map are constant. So our overall algorithm is linear, but because we are using a hash map, we are storing all the elements of our array into that hash map, and because of that, our space-time has gone from constant to linear, and that's why our memory has suffered a little bit. I still think this is a pretty big improvement, just because the runtime is so much more important here. Cool. We can actually improve this even further. We're unnecessarily looping through our array twice, right? We can actually, as we're looping through the array, do a lookup on the numbers that we've seen already. and see if we've already reached our target and exit early. And so let's take a look at what that looks like. Again, we'll need a hash map. We'll iterate. And unlike before, instead of directly adding to our hash map, we're going to calculate our second number first. And if num2 is in our hash map, then we can return right away. And that will be nummap num2. You'll notice that we don't have to do this additional check that we needed to add before because we haven't yet added our current index to our hash map. If we don't have a solution yet, then we add to our hash map. And then if we get through our full algorithm and we don't find a solution, then we'll raise an exception. So let's run our code and let's submit. And we see that our runtime has improved even further and our memory usage has improved compared to our last solution. And that's really because we added some logic that allows us to exit early, right? We may not be adding as many numbers into our hash map if we return early, hence our memory usage improving. And because we don't have to spend the extra time computing some extra operations, our runtime has also improved. Cool. So yeah, hopefully this video has been super helpful at explaining how one might approach this question in an interview. If you guys think this video was useful, please support by liking or subscribing to my channel. Thank you.